All right, yesterday we started working with linear and nonlinear and trying to figure it out from the slope-intercept form. And the way that we would figure that out, just as a little refresher, is if there's no exponent or no funky exponent, then we're good, and it needs to be able to go into slope-intercept form. Here I've got a little video, and I'm going to show you how to determine whether or not a function would be linear or nonlinear by using a table. And the way that you'll do that is by looking at that slope, so that change in y and that change in x. So here we'll look at the change in y first. First it goes from 1 to 4, which is a change of positive 3. And then our change in x is from 1 to 2, which is positive 1. So what we need is we need this change to either stay the same or we need it to be proportional. So even if we have a little bit of a change here, and I'll show you this proportional part in a minute, even if we have that little change, as long as it simplifies and the slope is the same, we'll be good. So I'll go back to this table. From 1 to 4 was plus 3. From 4 to 7 was plus 3. And from 7 to 10 was plus 3. So everything here checks out so far. On the x, from 1 to 2 was 1. From 2 to 3 is plus 1, and from 3 to 4 is plus 1. And I want to show you this proportional piece really quickly. So let's say that this x was 6. Well, that would mean that my y was plus 2. The way for this to stay linear, then my y would need to be 16, because from 10 to 16 is plus 6. And here, 3 over 1 is proportional or equivalent to 6 over 2. Now, it's unlikely that you're going to need to do this on any of the problems today, but just in case, if it's proportional, it's going to be linear. Now we're going to look at this other one and determine if it's linear or nonlinear. So our change in y, we're trying to find that slope. Our change in y from 1 to 4 is plus 3. Then from 4 to 9 is plus 5. And from 9 to 16 is plus 7. So this is already throwing up a little red flag for me here because it's changing. I just need to see if this change is proportional. If it is, then it will be linear. But here, from 2 to 4 is plus 2. From 4 to 5 is plus 1. And from 5 to 8 is plus 3. So this first change, I have plus 3 and plus 2. So that's 3 over 2. The next change that I have is plus 5 over 1. So 5 over 1. Are those proportional? Would they simplify to the same thing? And the answer is they would not. So this second table would be non-linear. A quick little review. You've got 6 problems that you're going to do at the bottom of this page, and you're going to put these tables in on your notes. So you'll put it in and you'll check to see x, y, and you'll fill it in, and this is the first one on that page. 3, 10, 6, 6, 9, 2, and 12, negative 2. So we'll look to see if this is linear. We're going to look at the slope. From 10 to 6 is minus 4. From 6 to 2, minus 4. From 2 to negative 2, minus 4. So far, this is looking good. It's checking out. Here, we're going from 3 to 6, which is plus 3. from 6 to 9, plus 3. From 9 to 12, plus 3. So all of our numbers that we have here are matching up. -4 plus 3, -4 plus 3. So I've given you number 14 here. Number 14 would be linear. So you'll show me the work and tell me the vocabulary word.